Okay, so till now that we have actually discussed about that how to use RoboFlow, how to prepare our data set, right? And how to actually label our data set, right? So we have seen the RoboFlow universe and other thing, that how to actually label the data set and try to export it in whichever YOLO model is preferable for our training part, right? So let's again move forward and carry this lecture to training the model, right? So as you can see that this is like I have already prepared one data set. Okay, so I will be downloading this data set, right, in YOLO V8 format. So till now you have just understood about all these part, right? Upload, annotation, data set, version, and other thing, right? So these images are already annotated, right, with some different class, and I will be downloading this data set, right? So I will not going to download it again because I have already downloaded here, right? So it's in here, in this here. So what I will do is this one. So let me show you the location that where I have downloaded this part, right? So it's already in this PP dataset, right? See this one. So this is how my data set is actually looking, right? So it has some test data, it has some validation data, it has some train data. Okay. Okay, if I go to data set, so you will find these many labeled data set. Okay, and the annotation part I have already done the annotation part, right? So these are actually the annotated image. Okay, and these are like the data version. Okay, which has 734 like images of test data, then validation data, and some of this data is actually under the training set, right? So once the data is actually downloaded, so now I will be using for training my model. Okay, so for that I will be using Colab. Why? Because it needs GPU for faster training. Okay, that's why. Now let me first open the Colab notebook here, right? Let me give some name. Okay, let me upload my YAML file or the zip file which I have already downloaded, right? So let me upload it here. It was actually in PP dataset, right? So PP, yeah, this one, right? So let it first upload it and then I will show it to you. Okay, so this data set is already uploaded. Now what are the things that I need for training? So I need to install first Ultralytics, where I can actually import the YOLO pre-trained model, right? So pip install Ultralytics, right? Now so this is installing. Now what else do I need? Do I need to download like install the pillow? I think yes, because for image pre-processing. So pip install pillow, right? Let me see, pip pillow, yeah, this one, pip install pillow, right? Now what I need to first import the YOLO model from Ultralytics, right? So from Ultralytics import YOLO, and then from pill import image, right? Okay, so these two I have already imported. Okay, now let me unzip my data. So for this I will be using unzip and then my data name. This has to be my PP dataset. As you can see that my data set is already unzipped, where I have data YML file, I have a training data, I have a testing data and its label. Similarly for validation data, it's image and its label. For training, image and its label. For testing, image and its label, right? Now I have all those ingredients ready. Okay, I have installed the Ultralytics. Okay, then I have installed the Piro library for doing the image pre-processing. Okay, and other things. Now what I need to do is that, do I need to do the OpenCV part? I think yes, we do need OpenCV. So let me use what is the standard library for OpenCV in pip. OpenCV. OpenCV pip right? This one. I need to install this also, right? Right now, what else do I need? So I have all the Ultralytics, I have Pillow, I have OpenCV, right? Now what I need to do, so we will again going to the Ultralytics documentation. As I already told you that always refer to the documentation. So let me just go to the Ultralytics documentation, this part. So you have all these things, right? So for me, I need to first train my model. So this is, I will go to the training tab, okay, and I will get these things, right? So the data set that which I have downloaded, right? So I have downloaded in YOLO V8 format, right? So you have these many format, okay? You can actually download it according to your requirement. So since I wanted to train it into the GPU, which is the Colab limited GPU, so I think that YOLO V8 would be sufficient enough for my training part. That's why. Let me go to the Ultralytics. So now from Ultralytics, I will be first importing the YOLO model, right? From here, I'll just copy and paste it. Now what I need to do, I need to import my model, right? So model equals, let's say YOLO, right? And then I will be importing this YOLO v8.pt file, right? I think this one. So it will start downloading the YOLO v8 model, which is already a pre-trained model, which has the limited trained on, which is like limited trained on the Coco dataset, which has 80 classes, okay? So this is my model. As you can see that this is my model. Now what I need to do, I need to do the training part, okay? Training part where on my own personal dataset, okay? Which can be anything. So here, before doing the training part, right, you need to first set up your training set file, testing set file, and validation set file into your YAML file, okay? As you can see that when I unzip my file, okay, after like downloading it from the RoboFlow, when I unzip it, then this is the file structure I'll get, okay? I'll get the YAML file, I'll get the validation directory, training directory, and testing directory, right? So in the YAML file, you need to do a little change. You need to give the proper file destination name, okay? So this is my testing file. So I'll just copy this path and I'll just paste it here. Okay, similarly, you need to give the location to validation file. Similarly for training file. Okay, now Control S, and these things, everything is ready. Now let's train our models. For training, we will again hop back to the documentation, right? So this model.train we need to call, which means that from the model subclass, I need to call the method which is called train. Okay, train method. So result is equals to model.train method. So this I need to call. And then instead of Coco 8 YAML file, we have our own YAML file, right? So I will just use these things. So results equals to model dot train, and here I will be passing this data.yaml file. Okay, data is equals to data.yaml file. So my first parameter would be data equals to, and I will going to give the location, right? Then in the second parameter, I need to give the number of epochs. Okay, so let me train for, let's say, 20 epochs. Okay, let me just copy paste it here. This, right? Let me just train it for 20 epochs. Okay, and then yeah, image size is around 640. I wanted to fix the image size, image resolution, okay, which means the height and width. Okay, and let's just train the model. So as you can see that my model start training, which means that whatever the YOLO pre-trained model I have, right, YOLO V8 model, so it will start training on our custom dataset, which I have already prepared and labeled it and download it in a zip format from RoboFlow universe. Okay, and then re-upload it into my Colab because it has a GPU. Okay, and then change the ML file location and change the file location of training and testing and validation file. Then again from Ultralytics, I am supposed to download my YOLO pre-trained model, and I will try to again run this command, which is like model.train model give it my data.yaml file location, and it will start training. As you can see that the training has started, so it will take some time. So once it once it stop training, so I will again come back to you. So as you can see that my model is completed the epochs. Okay, so I have just reduced the epoch to 10 epoch. Okay, otherwise it will take a lot of time. You can train it for more epoch if you want. Okay, so this model has been getting downloaded and in my local. Okay, so it is getting saved in content runs detect and then train to file. Okay, let's check runs detect and then this file, right? So I must be getting somewhere .pt file. Let me check. Where is the pt file? Okay, the pt file is basically in the weights inside the west. I am getting two pt file. The first is best.pt file and the second is last.pt file. Okay, so these are basically the trained on your pre-trained model. Okay, so first you have already imported the YOLO V8 pre-trained model. Over on top of that, you are actually training it on your custom data set on, let's say, based on multiple epochs that you wanted to train. Okay, so for now I have trained on 10 epochs. Now whatever the 10 epochs that I have trained, right, so the training result will be saved in .pt file, which means that I have the base model. Over on top of that, I am training on my custom data set, and then whatever the last model that I get, right, that will be my post trained model. Okay, so that has to be saved in .pt extension, right? Now that is so inside the weight you will see that I am getting the two .pt file. The first is best.pt file and the second is last.pt file. Now what is the difference? See, when it comes to last.pt file, it means that it is actually saving it from the last epoch. So after, let's say, from the last 10th epoch, whatever the model I have, right, the updated weight, so I have that last updated weight that is getting saved in last.pt file. And what is basically the best.pt file? So out of all the 10 epochs, right, whichever model in whichever epoch I am getting the best accuracy, okay, in terms of precision, recall and other things, so I will be saving it in best.pt file. That's the difference. That's it, right? Now can you tell me the difference between this YOLO V8 n.pt file and then these two pt file? These are basically your pre-trained pt file, right, which has not been trained in on a custom data set, and these are actually the best pt file or last.pt file is basically your own trained model, right, which has been trained on your custom data set. That is the difference, right? So from now we will be considering this model in order to predict our later doing the prediction. Okay, in order to do all the predictions in our data set. Okay, in the upcoming data set, right? So now let's say that in order to predict it, so what we're going to predict, we are just going to write model dot, because all these things are getting saved in my model, right? So this is basically the model. So if you can see this is basically YOLO model. I already told you about the YOLO model architecture, right? So what you need to do is that you just need to model dot predict, right? And inside the predict file, now what you need to do, you need to pass, let's say, any image. Okay, any image I want, right? So let me just take any image. So let's say interesting, I have some image, right? So let me just take this image, let me copy path, let me just paste it here. Okay, so I'm getting the prediction, but let me save it so that you will get a lot more good prediction, right? So let me save it in results, right? So let me save it in results. So if I look into the results, I have already shown you detection part, right? That how to do the object detection. The same thing, we have done it in the lot in the previous lecture, right? If I just going to print the result, so these are the detection I have got. Now let's say that if I really wanted to find out that how many what are the bounding boxes, then what should I find out? I should write result is equals to result of, let's say, 0. Okay, then 1 second, it has to be results dot 0, right? Results dot 0, right? And now let's say results null or result dot, let's say, let me just find out the length of result, right? So from that I will going to get that I have, so it has actually detected in this frame, it has actually detected the 4 bounding box. Okay, now let me just print the bounding box, that how does this bounding box looks, right? So result dot boxes, I would say, right? And it has to be, I guess xy, yes, it has to be xy, right? So these are the bounding box that I got, that is already in the pixelated format, which means 0 to 255, right? And let's say that if I want to if I want to show it over the image, so what do I need to do? Similarly, I have already told you, right? Plot method. See, these things you might be like, guess, like you might be thinking that how do I actually like know all these things, right? Because I have already done the ritual before. Okay, I have already done the data pre-processing part. I have already pre-trained the model. Okay, so the steps is like the steps I already like it basically wired in my memory. Okay, by practicing all these things, you will also get to know and all these things. So don't worry about it. Okay, so if I just go and write result.plot, so you can see that my image is getting plotted. So these are my testing images. So it is actually detecting the 62% confidence score, okay, to the person. Then these are basically the helmet. These are vest. It is also detecting, and in this way, it will start detecting the model. Okay. Similarly, if you want to check it some other image, let's check it. So let me just check it. This one, copy path. What I need to do, I just need to write it like update it here, right? Okay, it's the same image. One second. Let me take this image, right? Okay, so it has detected the helmet. So I think it is doing a pretty good detection, right? Now, if you really wanted to like understand about it, what are the number of classes I have, simply go to the data.yaml file and you will find out that I have basically these many classes. Okay, I have boots, helmet, person, vest. Okay, so some of these classes may not be present in your Coco dataset, but you have actually trained it on your own dataset, right? By labeling your dataset, by assigning class ID to it in this way, right? And you know all these things, like how to create all these things, right? So it is basically NC, which means the number of class, right? Now what I will be doing from now is that let's inference it. Okay, let's inference it on some video. Okay, so for that let me just download it. Like let me download any weight. Let me download the weights. Okay, this is basically train 2. Again, I'll go to weights, download the best.pt file, and then just do the download. So this is getting downloaded in my local system. Okay, so that I can actually surpass this to anyone who actually like wanted to use my model. Let's say that if I wanted to export this model so that it can actually run on my edge device, right? So how can I actually export it? Again, I will take help of the documentation part, right? So if I just go here in the documentation part, let me show you the documentation. This is the documentation. If I just go in the Ultralytics, right? So I will go to the export. Okay, inside the export, what I need to do is that I will just copy this part. That's it. Okay, model.export. That's it. So if I just go and just write it here, model.export, so that is basically ONNX, which means that ONNX is basically a universal way of downloading your pre-trained model. Okay, so the pre-trained model maybe have a lot of extension. Let's say the .pt extension you have, then let's say the TFRT TensorFlow extension you will be having. Okay, so .onx extension you will be having. Similarly, like running on the many multiple edge devices, you will be having a lot of extension, right? So if I just going to export it, so I will be exporting this model into my .onx, right? So it will start exporting the model. So let it first do, right? Okay, so my model is basically exported in test2 and then wait. If I go to the text2, if I go to wait, best.onx file. Okay, so this is also one of those export, like in a way you can actually export the model in different extension. Okay, let me see the other extension at what I have. Okay, so these are the extension you will be having. See, these are the extension you will be having. Okay, these are the export format. So as you can see that this is basically, if you wanted to export it in the format of PyTorch, you can export it, ONNX, OpenVINO, TensorRT, CoreML. So these are different export you wanted to try to export the model based on your use cases. Okay, so just follow this documentation, you will get to know about everything. Okay, so because I myself, like after gaining so much experience, I still follow this documentation, right? Because it is already properly managed, right? Now these things now, so I have already like, so let me download this ONNX model as well, right? So in my local system, if you see, right, in my local system, you will be getting the two model, right? One is like the .pt extension model and the other thing is like .onx model. Okay, so in my local system, if you see, right, in my local system, you will be getting the two model, right? One is like the .pt extension model and the other thing is like .onx model. Okay, Now what I'm supposed to do is that I will just run the same thing on, let's say, some kind of a video. Okay, some kind of a video I wanted to run. So let me just download it, any video, and then let me show it to you, right? So let's say some construction video. Okay, construction video. Let's say, let me download free videos from here. I need some worker. Okay, let's download. I think this looks good, a little blur, but I think this looks good. So let me download it with some extension. Let's say testing pp. Okay, so now my video is getting downloaded here, right? Now let me just like put it into the this one file, right? So this has to be like, let me copy it and let me paste it, the one which I've already showed you, yes, like showed you in the last video, okay, where I'm actually running the video inferencing. So let me just write it, like let me put it in this folder, and LMS experiment, I'm just putting this here. Okay, now let me run it again. So what I am doing is now the same code that which I've already like showed you in the last lecture. Okay, again I'll go to terminal, new terminal. Okay, and go to this location, activate my environment first, deactivate, right? Now let me activate the environment, which I have the command which is like source vnv/bin/activate. Okay, let me clear these things out. Now here I have the code in object detection.video file, right? So in ipvnby file I had this code, right, in this one. So this is my video, and this is my testing pp video, right? So let me just run it again, the same code guys. Again, I'm not doing anything, right? I'm just like loading the same model. So here what I need to do is that I need to give my downloaded model, okay, which I have already like trained it on my Colab GPU, right? So I need to give the location to that model as well. So what do I need to do is that, again, I will go here, go to my downloads, right? And this is my best.pt file, right? So I will just copy and drop it over in this one, in video, right? Object detection video part, right? So I have this this one model. I just copy it. Let's just copy the path, okay, and let me give it here in the video file, right? So let me increase it first, because you might not see all these things, right? So in the video one, object detection video, I have this ipvnb file. Okay, then I'm going to like locate my already downloaded model from the Colab, which I have already just downloaded it. I'm just going to give the location here, right? So this is my best one. Let me just rename it, because I think the one will not going to take a issue. So let me just write best.pt, that's it, right? So let me write best.pt here. So what I will do is that, okay, cool. Okay, so it has basically imported my model. Okay, so this is my model, like which I have just trained on my custom data set, okay, in Colab. So I have just downloaded it and given it the location and the entire same code, right? And this you already know, right? We have done it before. So this is like running it into on the video inferencing, right? So what is my video here? So my video would be somewhere here, like the construction testing pp video, this one, right? So I will just copy the path here and I'll just give it here. That's it. Control V, and then it is actually capturing frame by frame and it will running my model, right? So let's try to test it. So let me just test it on each 10 frame. Okay, now let's run it. So as you can see that, because even though it is actually blur, right, so it is actually able to try to detect it as a vest. Okay, so in this way you can actually test it. So similarly, let me just use some other clear video, right? So let me test it in this video as well, okay, that how my pre-trained model is actually working, right? 1 second, let me restart the kernel. Yeah, so as you can see that it is basically try to detect, right? So it is actually detecting person, it is detecting vest, it is detecting helmet, right, and other thing, right? So in this way you are supposed to test this model in this way. Okay, so now whatever the things that you have understood till now, right? So you have basically, like, again, let me go with the same flow, that whatever the things that you have understood, right? So first of all, you have understood about how to actually label the data set, right? Then after labeling the data set, you are supposed to like download the zip. Okay, and after downloading the zip, like in any GPU accessible system that you have, let's say GPU accessible system that you have, so from here, like in Colab, you'll just go to runtime, change runtime, and then change to GPU, and then save it. So the Colab will be having a whatever the free GPU you will be having it, then you can actually use it, right? So after that, you try to like upload your data set, right? So you will just upload the data set here, right? Upload the data set here. Then you try to like import the necessary model. Okay, imports, like you will do the import all this necessary model you have. So we have actually imported the Ultralytics, the OpenCV, the pillow libraries, and all these things, right? We have actually imported it, right? Now after doing this much kind of import and other things, now what we have to do is that we need to again load the model, okay, using the Ultralytics YOLO model, and then update the ML file, okay, give the actual file location of training, test, and validation, and then we will be using the model.train in order to train the model, right? Then after that, after doing the imports, then again we will going to update the ML file location, okay, and after doing the ML file location, again we are going to do model.train. Okay, after training the model, so my final, you will be getting two PT file, right? You will be getting best.pt file, okay, and then last.pt file, right? So you are already know the difference, right? What is the difference between the best.pt file and last.pt file? Okay, after like you get these kind of a .pt file location, then in order to run it in any other system, you will try to export it, right? So export in whichever comfortable and compatible system that you have. If you want to run it on edge device, then you may try to export it some, let's say in ONNX system, like in ONNX model. Okay, now let's say that if you want to export it in TensorRT format, you can actually use it in, like, try to export this .pt model into the TensorRT model as well. Okay, and different like PyTorch, so .pt model that you have, right? So you may try to export it on .pt model, you can try to export it, right? After exporting it, like, you may try to save it into your local system, right? So the model will be, let's say, downloaded, okay, so that you can actually perform the inferencing part. Okay, so you may actually perform the inferencing part, right? So these are basically a kind of total pipeline that we have actually discussed from right from the RoboFlow, from the data labeling part, like from doing the data augmentation part and other thing, right? And after that, defining it into different classes. And after defining into different classes, then what we have done is that we have actually downloaded our data into the YOLO compatible format in whichever YOLO version I want. Okay, after that, I go to Colab. Inside the Colab, I imported all those model. Then after like importing all this model, then I'll try to like upload my final data set there. Update the ML file. Okay, and after updating the ML file, then from the Ultralytics, I am going to download my .pt model, which means pre-trained model. Okay, and after that, I am going to train my model. Okay, so that my pre-trained model, after training with my custom data set, it is like we come in the process of post training, where like at the very last, at the end of this training epoch, we will be getting two model, which is like the best.pt model and then the last.pt model. Okay, based on our use case, we are supposed to like download the best.pt model, try to export it into the different system category, okay, in whichever we want, and then we try to do the inferencing on, let's say, video, on live streaming, on image part, in any way. Okay, now these things were the entire pipeline. So now, so after this video, like, I will be showing you that how you can actually monitor all these things. Okay, because as you can see that this is like completely vague, because you can't like show this monitoring to someone with just a number. Okay, you need to have like a good definite monitoring tool, so that you can actually confident enough to show your model more physically. Okay, so that you will be having like a different matrices and graph, and you will basically like do the live monitoring. Okay, that how your model is basically performing. So when it comes to monitoring tool, we will be using two things. Okay, the first thing that we are supposed to use is that we are supposed to use something called as MLflow. So MLflow, I will talk about this, and the second thing is WandB. Okay, so these two things are actually monitoring tool where you wanted to monitor the entire pipeline. Okay, So up till here, let me know if you have any issue, then we may discuss it. Otherwise, we can actually carry forward this video. Thank you.